Hi, my name's Abe. Welcome to part 2 of my walkthrough video of the 2009 methods paper, paper 1. And we're up to question 4 right now. So question 4 says solve the equation tan 2x equals root 3 for x inside that domain. What's tricky? Nothing, actually. Don't get thrown off by the domain. That is essentially just negative pi on 4 to 3 pi on 4 excluding pi on 4. Right? Cool. Nothing scary here. Although I do want you to think a couple of things. The first thing to think is how many solutions? How many solutions do you expect? So you know that tan has a period of pi ordinarily, so tan 2x is going to have a period of pi on 2, right? Now there's generally one solution per period, and the length of our or the size of our little interval, right? So from negative pi on 4 to 3 pi on 4 is pi. So if our period is pi on 2, we want 2 solutions, just generally. So just check things off in your mind. At the end, you should end up with 2 solutions unless something special happens. So this is how I'd go about solving the problem. You just go, okay, tan of 2x plus n pi is root 3, where n is some integer, right? So all I'm saying is tan 2x equals root 3, true, but tan 2x plus pi also equals root 3, because remember, if you add a period, doesn't change anything. Tan 2x minus 2 pi is also going to equal root 3, and so on. Put any number n inside, as long as n is an integer, that equation's true. Now, I'm going to do this so that you can find multiple solutions quickly. From the unit circle, you'll know that 2x plus n pi is equal to pi on 3, right? Because tan of pi on 3 is equal to root 3. Okay, so then you just solve for x. So, you get 2x equals pi on 3 minus n pi. Now, make your life easy, I'm going to say 3n pi on 3. Right? So that's just n pi. And to make life even easier, you can take out pi on 3 and then 1 on 1 minus 3n. Sorry, slight blank. And even better, you can just say, okay, x equals pi on 6 times 1 minus 3n. There you go. Found x already. All you need to do to get the solution is to sub in different values of x. Easy, isn't it? So at x equals 0, sorry, not x, sub in different values of n, and you'll get x. So at n equals 0, x is just going to equal pi on 6 times 1, which equals what? Pi on 6. And you just check if pi on 6 is inside our range. It is, isn't it? Right? So this fits because pi on 6 is between negative pi on 4 and 3 pi on 4. And also, it is not pi on 4. So it fits. Pi on 6 gets a tick. Good stuff. Okay, what about n equals 1? X is going to equal pi on 6 times minus 2. Negative pi on 3. Does this fit in the range? No. Negative pi on 3 is more negative than negative pi on 4, so that doesn't go. So, you know that if you keep increasing n, you're just going to get further and further away, right? So we went from 0 to 1, so maybe let's now try n equals negative 1. X equals, what? Pi on 6. And then, if you put negative 1 in there, you're going to get 4. So 4 pi on 6, or 2 pi on 3. Does 2 pi on 3 work? Yeah, 2 pi on 3 is smaller than 3 pi on 4, isn't it? And also, it is not pi on 4. Tick. Okay, you've got your 2 solutions. Now, you know that if you were to add any more, because each time you add, you put in an n, so if you were to put in n equals negative 2, right, you'd get you'd get x equals 7 pound 6, which is definitely bigger than 3 pound 4. So you know that's not going to work. So there you go. Our two solutions are here. Found. And at the very bottom, remember, you need to give them the answers. You can't just leave it like this. You're just going to say x equals pi on 6 to pi on 3. Done. Question 4. On to question 5. Question 5 says 4 identical balls are numbered 1, 2, 3, and 4 and put into a box. A ball is randomly drawn from the box and not returned to the box. A second ball is then randomly drawn from the box. And part A goes, find, or what is the probability that the first ball drawn is numbered 4 and the second ball drawn is numbered 1? Okay, very simple question. You're not returning these balls to the box. There's 4 of them, right? So there's 2 separate events going on. First thing, first ball drawn is equal to 4. Well, that's just going to be one of the 4 balls is going to fulfill this criteria. So, 1/4, right? What about the second part? So after 4, let's say this happens, right? So you've got 1, 2, 3 left in the box, and the second ball drawn is 1. There's a chance of 1 in 3 chance of that happening. There you go. 1/4 times a third is 1 on 12. Notice that there's only one way for this thing to happen, right? You need a 4 on the first ball and a 1 on the second ball. And that's it. Part A is a free question. On to part B. So part B says, what is the probability that the sum of the numbers on the 2 balls is 5? So we determined in the first part that if you want some combination of 2 balls, the probability is 1/12. Notice that it didn't have to be first ball 4 and second ball 1 for this to be true. It could have been first ball 3, second ball 2, or first ball 4, second ball 2. Anything like that, right? So basically, you just think of all the combinations you could get that'll sum to 5. So, writing them down, you can pick out a 1, then a 4, that'll do it for you. Or a 4, then a 1, that'll do it for you. Or 2, then 3, that would work. 3, then 2, that would also work, right? Notice that there's no other combinations in there that it's going to give you a 5. And so, okay, being nice, you should write probability. So let's add that to part A. And so probability of the sum of 2 balls coming to 5 is going to be 4 times 1/12 is going to be 1/3. So there, part B out of the way. Also fairly simply. On to part C. Part C says, given that the sum of the numbers on the 2 balls is 5, what is the probability that the second ball drawn is numbered 1? Okay, the key word, given. Given. So when you see given, you should use the given formula, right? So it helps to write this down. And you should know what it is. Probability of A given B is the probability of A intersection B over the probability of B. Yeah? Easy. Okay. And you should also identify A and B. So in this case, I've written the question nicely for you, but that is A, isn't it? So this is the event that's going to happen, and this is the given condition here, B. So you just put these 2 events together. Fairly simple. So you want the second ball, okay, the first, so probability of A intersection B is the second ball equals 1 and the sum of the 2 balls equal to 5. There's only one way for that to happen, isn't it? You need, obviously, a 4 and then a 1. So probability of A intersection B is going to be 1/12. Okay, so I'm just going to write PR A intersection B over PR B. A intersection B is 1 on 12. Probability of B, sum of two balls equal to 5. Well, we found that in part B, didn't we? It's 1/3. 1/12 over 1/3 is going to give you 1/4. And that's it. Not too difficult. Don't get sucked in by the given questions. If you just look at the question, you'll be like, what do you mean? I don't even know conceptually how this is going to work. But plug it into the formula. Use the given formula when the word given appears in the question. I think that's the best advice I can give you on that part. Alright, on to question 6. Actually, that'll happen in part 3 of this video. Hope to see you there.